let's record it. Okay. What is the fundamental lens equation and the magnification equation? Okay, so we're going to talk about lenses now. So lenses work differently than mirrors. We'll do one more lab with mirrors, but I'm doing this lab at the same time as Physics 1, so it just makes sense to set it up for everybody at the same time. So the equation for lenses is 1 over F equals 1 over DO plus 1 over DI. Don't worry about the symbols. I'll tell you what they mean in a second. Okay. And then the other one is M equals HI over HO equals negative DI over DO. So first of all, you've seen this 1 over business. So this is adding inverses. So you've seen this before when we did electricity. So the whole 1 over, 1 over, 1 over should not be new. And we've seen this with multiple equal signs. It just means that you ignore one of the three things. So like, for example, if you're solving for M and you know HI and HO, you just ignore DI and DO and you solve the what's left. Okay? Likewise, if you don't know the magnification, but you do know the heights, you ignore the magnification and you solve DI, DO that way. So you just cover up one thing that you don't need and you solve the rest of it. That's how that equation works. Okay, so what do all the variables stand for? F is focal length. Okay, focal length is how far the focal point is. So that's nothing new to you. DO is object distance, and it's the object distance from the lens. DI is the image distance. Also from the lens. M is magnification. So how big or small it looks. HI is image height. And HO is object height. Okay? All right, what's the sign plus or minus for the magnification tell you about the image? So plus sign means virtual. So a positive magnification is virtual. A negative magnification is real. Are those words funny?
It's almost like you're saying virtual isn't real.
That is kind of what I'm saying. What does the magnification mean if it's bigger or smaller than 1? Okay. If magnification is larger than 1, okay, then the image is larger than the object. If the magnification is less than 1, then the image is less than the object. Okay, I have a lot of lenses for my telescope, and they have different X's on them, magnifications. And so there'll be 2 times or 10 times or 4 times. It's how much bigger the object looks than the actual thing. So if you look at one of the planets, say Saturn, with your eye, and you look at it, it looks like a star. It's a little pinprick in the sky. But if you look at it through the telescope, it'll look larger than that pinprick. And how much larger depends on what the magnification is. So anything that's larger than 1 is going to be a larger image than the object, so it will be expanded. And anything less than 1 will be, the image will be shrunk. Just as a thing too, so anything that's virtual will be positive, right side up. Anything that's real will be upside down. So let's see if any of you can make a guess. Objects that you look at in a telescope, are they right side up or upside down? They are upside down. Because a telescope makes a real image. So what you're seeing in the telescope is actually upside down. So when you look at the planets, what you're actually seeing is the planets upside down. That doesn't matter, though, because what's upside down in space? Like, yeah, we don't know, right? Like, which is, like, are we pointing up? The people on the other side of the Earth are pointing down, but are they pointing? There is no up or down in space. So it doesn't matter if it's upside down when you look at it, because it's just, you're looking at it.
Hypothetically, you're standing on the ceiling.
Yeah, something like that. Yeah.
How does it work for your eyes?
What do you mean? Oh, you see the world upside down. Your brain flips it so it looks right side up. But the actual image is upside down in your eye. He doesn't, Ethan doesn't like that. Yeah.
Can you like break your eyes to see everything upside down?
No, there was a guy one time who wore goggles that flipped the image before it went in his eye. So it went in his eye right side up, and he saw everything is upside down. But after like a couple months of wearing these goggles all the time, his brain flipped it again, and so he did everything normal again. And then he took them off, and then he was all messed up again.
This is awesome.
So your brain can like train you to do weird stuff. But yeah, your brain's messed up. All right. So let's get started on the lab.